Okay. The computer memory, when we talk about the digits 1 and 0, one digit or the one binary digit is the bit. Okay. Then 4 bits, it's a nibble. 8 bits is the byte. You have heard the byte, like for example, in the size of the memory, gigabytes, GB, that is gigabytes. The byte is the smallest unit of memory of the computer system. The memory sizes can be 8 in the multiples of 8. 16-bit, 32-bit, and I showed you this last time, 64-bit, okay? Or 64-bit operating systems. 64-bit means that the operating system or the hardware, it works with the combination of 64 bits. So of course, more places are available, and that will increase the space for the for the memory to work. Now, you might have seen this as KB, or generally we call it kilobytes, or MBs, megabytes, GB, gigabytes, and terabytes. Even the hard drive, they are now 1 terabytes, 1 TB, 2 TB. But actually, when we are talking about the memory or the computers, these are kibibyte, mebibyte, gibibyte, and tebibyte. I know it's very weird names, but why are these different? Because it is equivalent to, again, in the powers of 2. 1024, 1024 power 2, 1024 power 3, and 1024 power 4. It is not 1000. When we are talking about kilo, the kilo value is actually 1000, right? And for mega, it's 1000 power 2, meaning jitna bhi 1000 uska banta. So actual numbers, actual names are like this, but because the consumer or the customers, they were not familiar with these different kinds of names, so general names are being now used. But when you talk about the memory, it is not in the power of thousands, but it is in the power of 1024. Just the power, 10 power. Okay. Gigabyte, terabyte, petabyte, that is 1 PT. Now coming to the binary system and the denary system conversions. We know that basically the binary systems, they are representing some kind of the numbers that we are familiar with, that is the decimal number system. But the computer needs to exchange it or convert it into the binary numbers. We don't need to do any kind of programming for that, but we need to understand it, how the conversion works. Now, look at this. We have 2 power 0. The easiest way to write is base 2 power 0. 2 power 1, 2 power 2, 2 power 3. And once you keep practicing, you will, it will be very easy to remember 1, 2, 4, 8, 16, 32, 64, and 128. This is the 8-bit system. This is what we'll be working with in this chapter, 8-bit combinations. If we have a denary number 24, to represent it in binary, what do we need to do? What do you think? How do you think that it knows that 16 hai ya 8 hai? Yeah, we do write 1, but how do we know that which place should be 1? What you were going to do is you're going to see the decimal number 24, then look which is the smaller number from 24. Look at the this 64, 32, and then 16. We cannot assign 32 the value 1 because otherwise that will be higher than 24. So we are looking for the lower value or the lowermost value 16. Now we now have 16 from 24. You subtract it. What is the result? 8, 8. Okay, and now we know this is 8. So 16 plus 8 will give us 24. That means that these bits are 1 or these bits are on. The rest are all zeros. 1, 1, 0, 0, 0. But when you are writing in binary, you never write it like this. In decimal, to hum likh sakte hain 24 or like 4 or 2, even like that. We don't need to write the leading zeros. But when you are talking about the 8-bit system, we always have to complete the full 8 bits. So if there is nothing before this, you need to add the zeros. Okay. So 0, 0, the binary number is 0, 0, 0, 1, 1, 0, 0, 0. So this is one way to calculate the binary number. Again, 43, lesser number will be 32. So you minus 11, then not 16, 8 is lesser, 3, that is 4 is higher than 3, so we make it 0, 2, and then 1. So all of these added will give you 43. And wherever you get the number, you will write 1. That means this position is on. And 1, 2, 3, 4, 5, 6, and 7, 8. 2 leading zeros. So this explanation is given over here. To convert the denary number 75 into binary, you find the lesser number 64, mark 1 there, you subtract, which is then it gives you 11, then 8, 11 minus 8 is 3, 2, and 1. Repeat until same as a denary number, mark the rest as 0. Another method is to do something like this. You keep dividing the number from 2. It's written like this. You make a table. You write the denary number 91 and you keep dividing by 2. 91 divided by 2 is 45. This is because it's all divided by 2, so you can do it mentally. Divided by 2 will give you 9. Sorry, multiplied by 45 will give you 90, not 91. 90. Okay, na? Ye 91 divided by 2, 4s are 8, 1, 1, 5. So हमारे पास remainder क्या है? 1. So this remainder is what we write over here. Not here. ये वाला इसके साथ नहीं है. The top one. Then again we keep dividing by 2. Again 22, remainder is 1. We write it over here. 11, the remainder is 0. 11 multiplied by 2 is 22. 11 divided by 2 is 5. Remainder and remainder. Let's do it over separately. 91. Okay, one more thing. Yes, it's not necessary that you have to write with the top number. You just need to write the remainder. कोई इसमें कोई एक set rule नहीं है. You can write it like this. 2 and 2s are 4, 1 remainder, 11, 0 remainder, 5, 1 remainder, 2, 2s are 4, 1 remainder, and 2, 1, and then 0. Now we have all these remainders. What do we need to do? You start from here, you go up, and you start writing the number 1, 0, 1, 1, 0, 1, 1. And you again complete the bits 1, 2, 3, 4, 5, 6, 7, and then 8. You add a 0. Always add the 0 before. add a leading zero, not the following zero. How to check your answer? Yes, you will check your answer. पहला हमारे पास क्या था? 1, 2, 4, 8, 16, 32, 64 and 128. These are on, so we are going to add it. 64 plus 16 plus 8 plus 2 plus 1. Hopefully we have it. This is 80 and this is 11, which we have as 91. Okay, whenever you do any kind of conversion, always convert it back and check if you have the correct answer. Okay, the answer can be checked. This. Now, binary combinations. As we said, we are using the 8-bit system. If we have a single bit system, the either, what values can it have? 0 or 1. 1 bit will have 0 or 1. 2 bits will have combinations. You are doing maths, right? Combinations जो हम उसमें stats में करते हैं. But how many combinations are possible with 2 bits? 4, which are 0, 0, 0, 1, 1, 0 or 1, 1. Okay, all kinds of combinations which are in denary 0, 1, 2 and 3. These are mentioned over here, denary number. And same way, if we have a 3-bit system, we have 2 power 3 combinations, which are 8 combinations possible. And whenever we have 8 combinations, that is from 0 to 7. So how to write this table? The easiest way, ठीक है, अगर हम here 0, 1, 2, 3, 4. I don't know what's happening with the pen. 5, 6, 7 and 8 आएगा नीचे. What you need to do? You start with 0 from the top. 0. This least significant bit on the right side. This is the right hand side. ठीक है, of the number. So what you need to do is 0, 1, 0, 1, 0, 1, 0, 1 और एक last में आ जाएगा हमारे पास 0. When you go to the second bit, you write 2 times 0, 0, 1, 1, 0, 0, 1, 1 and 0. Third, you write it 4 times. 2 power 3 है ना combinations हमारे पास. So like this. अच्छा 8 तो हमने लिखना नहीं है. This is 7. It is from 0 to 7. 8-bit combinations are from 0 to 7. We always start from 0. Remember this. It's not 1 to 8. It's 0 to 7. So these are the combinations. You don't need to divide from 2 or for every number. Once you make the whole table, it will be easier for you. Mostly in the combinations or when you have another system, you will need to use this. Okay, the rule is the right hand side 0, 1, 0, 1, 0, 1, then 0, 0, 1, 1, 0, 0. You can also check 0, 0, 1 is 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4. How is 1, 0, 0, 4? ठीक है, 1 इधर जो है हमारी 1 होते हैं, 2 होता है, 4 होता है, so 4 plus 0 plus 0. Confusing हो रहा है? Let's do some practice. Okay. First, let's do some conversion questions. Okay. This one. Find the binary equivalent of the binary number 113. 113. And then check your answer by using the appropriate place values.